Python 3, perfect alphabetical order. The goal of the code is to find the longest alphabetical substring within a string. When I run this code, it gives apt as the longest substring, when it's actually ABCD. This is because it checks the character A, comparing it to the next in the sequence, and then adds A to B giving up. Then it checks B, comparing to C and adds BC together, and then adds BC to up. To fix this, I've been attempting to make the loop skip the next character if it's in alphabetical order already, and check the next one by increasing the value of n once the condition is met, but this doesn't seem to do anything at all. Advice, tips, corrections, and harsh criticism are all welcomed. Edit, it appears I've misled some of you, so I apologize. What I meant was that if I have a string, it extracts the longest possible substring in alphabetical order. In the case of zizpdes, it will extract BCDZZZ because that's the longest possible alphabetical order substring, not BCDE. The problem with my current code is that it gives pdes. If I could skip one loop when the first if condition is true, then I think it might work in my code.
TLDR, and the last code after the edit solves the problem. This is a variant of the longest common substring problem. Credits to this post for the subroutine. Edit. It seems like the above code doesn't work for all cases, so I had to redesign the function. Output. This works on the assumption that the substring should always begin with A. This iterates through every possible substring from OR, AB, ABC, up to the full string of alphabets and then stores the longest substring encountered in the check. For the sake of completeness, here is the code that would work for any longest common substring. Where one string contains the alphabets in order and the other contains the test string. Be aware that this is n squared, it's in complexity, not that it matters for small cases.
A different version looping over zip, strg, one column, in order to compare the previous and the current character in the same loop iteration. Comparing the characters with OR this way has the disadvantage that these characters $% and *+ comma ./012345678 column equals *@ ABCDFGHIJKLMNOPQRSTUVWXYZ *ABCDFGHIJKLMNOPQRSTUVWXYZ will be considered as in alphabetical order. You may need to tweak that to your needs.
From an algorithmic perspective, the most optimized approach is using a suffix tree in order to find the longest substring in a given string. I've implemented an optimized version of the suffix tree in Python a while ago. In case you're interested, you can check this URL. As another hacky way, you can utilize the numpy in order to find the largest substring using the difference, where, and split functions. Explanation. The logic behind this code is to find the indices of the characters that the difference of their ASCII value is 1. In numpy, we can simply do that by np.difference function. But since it needs an array of items, we can use a list comprehension to pass the list of intended values to the function. Then by comparing the result with 1, we can get a list of bool array as follows. Now we can get the indices of the false items using np.where to pass them to split function. The +1 is actually because np.split splits from 0 to our first index and then from first index to the next and etc. And at the end, we can get the longest array using max function by passing the len as the key function. Also note that this approach will give you the longest consecutive sequence. If you just care about the order, you can replace the equals 1 with is greater than 0. Here is an example.
Here's a simple, efficient and, quite readable solution, which dodges the "what does alphabetical order actually mean" issue by taking a custom test function as a parameter. You can use it e.g. like this, which will print ABCD. If you'd like to use a case-insensitive comparison and/or to ignore non-alphabetic characters entirely, you can do that by changing the test function, e.g. like this. Of course, by defining a suitable test function, you can also use the same longest matching substring function to find the longest consecutive substring where the adjacent pairs of characters satisfy any arbitrary criterion, like, say, does not contain a consonant followed by a vowel. And you can even use the same function for finding longest matching consecutive subsequences in other sequence types like lists and tuples, not just in strings. This implementation does not, however, work for arbitrary iterable types. To handle those, we'd have to memorize the current and the longest matching substring as we iterate over the input. While doable, that would somewhat complicate the code and also make it less efficient for ordinary strings and other sequence types.
If you watch the channel, please consider liking and subscribing.